Hey everyone. The instructions say to multiply the following expressions. There are three separate problems to work here. In each case, we're multiplying terms that have a base and an exponent. And in each case, the base is always the same. All the bases here are x, here they're y, and here the base is 3 in both cases. So to multiply expressions like this, we're going to use what's called a product rule. And here's what the product rule tells us. If you take x to the m times x to the n, it's going to equal to x to the m plus n. The base doesn't change, and the exponent is just the sum of the two exponents here and here. Now we can show why that's the case. It may be obvious, but in case it's not obvious, let me show you. It's pretty simple. Say we have x squared times x to the third. If we wanted to multiply these two things together, we could write them without the exponents. X times x is x squared. Bring down my multiplication symbol there. X cubed could be written as x times x times x. So what do we got here? X times x times x times x times x. We're multiplying 5 x's together. So all we really had to do is add the two exponents together to get x to the fifth. Now, of course, when the exponents are small like this, you could write them all out, no big deal. But if we had x to the 20th times x to the 30th, we sure don't want to write out that many x's, and we don't have to. All we have to do is add the exponents together. And just keep in mind that this only makes sense or will only work if the base is the same. Alright, let's look at the problems that we were asked to solve here, that we're asked to simplify. We want to multiply these things together. The bases are all alike, so it's going to be x to the, well, 5 and 3 is 8. 8 and 4 is 12, x to the 12th, and that's it. That's all we got to do. Here, the bases, they're all y. We don't see an exponent on this guy here, but when you don't see an exponent, it's understood to be a 1. In the same way, when you have x and you don't see anything in front, there's understood to be a 1 in front. Right? So we need to count that exponent, even though it wasn't visible. So if we add up all the exponents, we're going to have 2 plus 1 is 3. 3 plus 11 is 14, so it's going to be y to the 14th. For the last one, it's pretty tempting to say 3 times 3, oh, there's 9, and then we add the exponents and we get 6. But that's not right. In these cases, we didn't change the base. We kept the base that we had. Kept the y as the base. We kept x as the base. So the same thing has to happen here. It's just not, we're just going to have, instead of this, we're going to have 3 to the 6th power. The base can't change. Quickly, you could illustrate this because the exponents are kind of small. We could write this as 3 times 3. We could write this one as 3 times 3 times 3 times 3. So yeah, we're multiplying 6 things together here. But what are we multiplying together? We're not multiplying 9s together. We're multiplying a bunch of 3s together. In fact, we're multiplying 6 3s together, so we get 3 to the 6th.